Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2018 TZ0 in November. The really kind of meeting the last multiple choice question number 39. Stuff related to topic 11, a really non-chemistry topic about the error propagation. A really important concept still because students are always be using the error propagation to deal with the IA issues, right? The internal assessment, which is important for the error propagation in terms of the data interpretation. Let's see, what are the absolute and percentage uncertainties for the change in mass for this case, right? So given that the initial and final mass with absolute uncertainties following. So remember, all the stuff following the data expression is what we call the absolute error, or so-called the absolute uncertainties, right? So remember, when we do the mass change, what we should do first is by doing a subtraction for the data, right? Because change means final minus initial, a simple mathematics, right? So that's why the mass change in mass obviously will be 42.35 subtract the 22.35, right? So obviously the answer is going to be 20.00, right? So that's why the change in mass will be equals to the 20.00 grams, right? But to how much of the absolute error is that? Remember, whenever it is going to be an addition or subtraction, addition of or subtraction of data, for the absolute error must be added up, because errors can only be accumulated but not be eliminated. So that's why accumulating error is a must-have procedure. No matter how many times we measure the mass, every time we measure the mass, there will be subjected to an error. So that's why no matter how we do the calculation, errors can only be accumulated but not be reduced. Yeah, unless we change the procedures or protocols, right? So that's why in this case, the change in mass is subtraction, true, but the absolute error must be having addition in case of data addition and data subtraction, right? So that's why in this case, I will simply add up the absolute error. So that will be equivalent to 0.10 grams, right? And one more thing that students always kind of miss it out is that, remember, the decimal place for the data must be equivalent to the decimal place of your error expression. Otherwise, the full presentation is not going to be correct. So that's why don't forget that to put 20.00. These double O's are still what we call the significant figures, remember. So that's why obviously absolute uncertainty will be 0.10. So answer B or D. So next, percentage uncertainty. The next thing about the concept is what is meant by percentage uncertainty. Simply means the absolute error over your measured value times 100%. So that's why after we arrive to the answer, the percentage error or the percentage uncertainty, which simply means the absolute error 0.10 over the measured value. So in this case 20.00, right? Referring to the same thing, right? True times 100%. Right? So obviously will be a factor of 5. Why? Because 1 over 2. You don't really need to work it out because calculator is not provided, right? But at least you know here having a factor of 1, here having a factor of 2, and 1 over 2. So that is a factor of 5, right? Yeah, and the 100% won't affect any of the number, but just move the decimal more forward, right? So that's why answer will be with a factor of 5. So that's why obviously answer will be B.